Hi, I want to give you a formula how to determine a decay rate. So this formula is algebra based. You've maybe learned a different one in your math class. There's an integrated form that I'll show you as well. But know that there are a couple of different formulas. They're just all variations of one another that you can use. This is what I use for my honors chemistry class, so maybe like a pre-college, or I'm getting ready for a general chemistry class. So here we have it. N equals n sub naught times 1/2 raised to the big T divided by the T to the 1/2, sub 1/2. So I've labeled everything for you. This n is going to be the amount remaining. What's left over after we've had a certain time elapse and this substance has begun to decay. N sub naught, that's the amount that you begin with. There's your initial amount. 1/2, and then this capital T, that's the time elapsed. And the T sub 1/2, you'll recall that is our symbol for half-life. How long it takes for half of the reactants to change to products. So I have a couple of examples here. I want you to keep this in mind as we do them. The T over T sub 1/2, so the time elapsed divided by the half-life, that could also be calculated or symbolized by the letter N, and that's simply the number of half-lives that have elapsed, and I'll show you that as well. I could have actually just put N right there. Okay, so two problems to help you understand this. The first one, the initial amount is going to be 10 grams of our substance. The half-life for this substance is 2 days. We're going to go 8 days. 8 days are going to elapse. And so then we ask, what's the amount remaining? Now, some of you might be watching this and go, well, I can do that in my head. And the answer is yes, you can do this in your head, because you probably see it's going to end on a perfect half-life. Let's go ahead and use this formula, and it will confirm what you're thinking, maybe graphically or using mental math. So let's label everything that we have. The initial amount, that's your N naught, equals the 10 grams. Let's see, the half-life, that's your T sub 1/2, is 2 days. And then the time elapsed, that's your capital T, that's 8 days. And what we're looking for is the amount remaining, N. That's the question. So let's go ahead and plug into our formula right here. N, that's our unknown, will equal the initial amount, which was 10 grams, times 1/2 raised to the big T, that's the time elapsed, that was 8 days, divided by the half-life, which was 2 days. Okay, two things that I'd like to point out. Be really careful that the time for time elapsed and half-life, they have to be the same unit of time. So if you have one in years and one in days, you need to convert them to be the same unit. Doesn't matter which unit, they just have to be the same unit. So when you divide them, you can see that those units will cancel out. Second thing that I want to point out is this fact right here. Here's my question for you. How many half-lives did this substance undergo? How many times did it divide in half? 8 divided by 2 gives you 4. So N in this example, the little n would be 4 half-lives. So that means it divided in half, divided in half, divided in half, divided in half. And for those of you who saw it graphically, you could go, oh yeah, went from the whole to 50%, 25%, 12.5%, 6.25%. It divided in half 4 times. Well, let's go ahead and put this in our calculator. If I take 1/2 raised to 4, that is actually 0.0625 times 10 grams equals N, which means N, so the amount remaining, what's left over, is going to be our 0.625 grams, 0.625 grams. So there's your answer. This underwent 4 half-lives, started with the 10 grams, and we ended with the 0.625. So it's really just a plug and chug once you get everything labeled. Okay, let's do another one. On this next one, question number 2, the half-life is going to be 22 days. It tells us what's remaining. We have 25 grams left over remaining. The time elapsed is 50 days, and we want to know, well, what's the initial amount? So let's go ahead and label everything here. Our half-life is the 22 days. Now the amount remaining, that's N. That's going to be your 25 milligrams. Time elapsed, we've had 50 days have elapsed. And we want to know what's the initial amount. How much did we begin with? Okay, now for this one, you can see mathematically when we divide the time elapsed by the half-life, it doesn't give us a nice even number. It doesn't give us just, hey, here are 4 half-lives like we had over here. So whenever you have your n, the number of half-lives, if they don't end on a whole number, you cannot do mental math. You can't do this graphically. You're going to have to do the algebra. So let's go ahead and plug everything in. We're going to have the amount remaining was 25 milligrams equals n naught, that's my unknown, times 1/2 raised to the time elapsed is 50 days divided by the half-life was 22 days. Now, if we divide 50 by 22, that is going to give us 2.27. I'll make a note up here, is 2.27. So we didn't end on a perfect half-life. I can't do the mental math of, okay, well, if I go 1 half-life, that's divided in half, that'd be 50%. Second half-life is going to be down to 25%, divide 50 by 2 gives me 25%. But then I have to go 0.27 of a half-life. So we're just going to have to put this into our calculator. And you'll do 1/2 raised to the 2.27. And when we do that, you get 0.206. Okay, so 1/2 raised to the 50 divided by 22, that 2.27. And that would make sense because remember, a second half-life is 25% remaining, third half-life 12.5%. So we're going to be somewhere between that 0.25 and the 0.125. Yep, we are, for the 20%. Okay, this is going to be times the initial amount equals the 25 milligrams. So let's go ahead and divide both sides by 0.206. 0.206, that cancels out. Notice the days canceled out. I have milligrams right here, so our final answer will be milligrams. And we began with, so the initial amount was 121 milligrams. Okay, now think about this with me, 121 milligrams. If it underwent 1 half-life, that would give us about 60 milligrams. Underwent a second half-life, divide 60 by 2, is 30 milligrams, and then it went through a 0.27. So almost in it. If it went a third half-life, that would be 15, but it didn't go quite a third half-life, so it ended at 25. Between the 30 and the 15, that would be a second half-life and a third half-life. But you've just got to put it in your calculator to get that value exactly. Okay, nice. So a couple of examples using an algebra formula to determine the rate of decay. If you are a little more advanced in your math, I have an integrated formula for you that you can watch in the next video. Thanks, have a nice day.